All right, guys, so we're taking a look at some solving inequalities notes, so some stuff we did in class, okay? So notice we've got a similar looking situation across each number, okay? So for number 1, if we were to solve this, we'd start by subtracting by 10. 12 minus 10 would give us 2. 2 equals x over 4. And we'd multiply by 4 on both sides, giving us 8 equals, those would become 1. We get 8 equals x. Okay. Number 2, if we were to deal with this inequality, we start by subtracting by 10. We get 2 is less than or equal to x over 4. This becomes 0, so it cancels out because adding 0 does nothing. Times by 4. And we get 8 is less than or equal to, and this becomes 1. Timesing by 1 does nothing. Okay. Now the next step. We would add 9 to both sides, giving us negative 10x equals 200. Divide by negative 10, and we'd get x equals negative 20. Okay, for number 4, we add 9 to both sides, giving us negative 10x is greater than 200. Divide by negative 10, and we get positive x is less than negative 20. Okay, next one, we would start by multiplying by 4 on both sides. That would become 1. We get rid of it, n plus 9 equals 3 times 4 is 12. Subtract 9, and n equals 3. For number 6, start it the same way. Times by 4. That becomes 1, which timesing by 1 does nothing, so we eliminate it. We get n plus 9 is less than 12. Subtract 9. N is less than 3. For number 7, we kind of ran out of space, didn't we? 7 and 8. So we'll do our best. So let's distribute. We get negative 90 minus 9x equals negative 99. Add 90. We get negative 9x equals negative 9. Divide by negative 9. And we get x equals 1. Number 8, negative 90 minus negative 9 is less than negative 99. Oops, minus 9x there. Sorry, that was weird. I don't know what I was thinking there. So, minus 9x, there we go. Add 90 to both sides. We get negative 9x is less than negative 9. Divide by negative 9. We get x is greater than positive 1. All right, so first question here, I guess not first question. What do you notice about the equations and the inequalities that is similar? So what do we notice about these that's the same? What you should notice is we've got the same numbers, don't we? We also are doing the same steps. Subtracting, timesing, adding, dividing, timesing, subtracting, distribution, adding, dividing, okay? So that's some similarities, right? So what would we say here? The numbers, the steps to solve, those were all the same, weren't they? Okay, so now what is different? What do we notice that's different? Well, we should notice that this has an equal sign, this has an inequality sign. Okay, that's one thing to notice. Also, our answers are different, right? Because n equals a number means that one number is correct. N is less than 3 means that 2 could be an answer, 1 could be an answer, negative 1 could be an answer, right? Any other differences we see? There's another one that we should notice. So, but I want to go to the next page to talk about that one, because I want us to do this right here. Okay. So let's use this inequality. We've got negative 9 is less than 2. Okay? So what we're going to do is we're going to do what it tells us here. See what that equals. So we start out with negative 9 is less than 2 on everything. And then we're going to say if it's still true or false. So the example here, they added 3 to both sides. Okay, adding 3 to both sides, it maintained its inequality. It was still true. Okay, so we subtract 7 from both sides. So negative 9 minus 7, is it still less than 2 minus 7? Negative 9 minus 7 is going to be negative 16. Is that less than 2 minus 7 is negative 5? Yes, negative 16 is less than negative 5, so that would be true. Okay, now let's try the next one. We add 15 to both sides. We have 17. Is that greater than negative 9 plus 15 would give us positive 6. Yes, 6 is less than 17. That is true. Add negative 10 to both sides. Negative 9 plus negative 10 is going to give us negative 19. 2 plus negative 10 is going to give us negative 8. And yes, negative 19 is less than negative 8. You may be thinking, well, it's all true, so what does it matter? Let's keep going. Negative 9 times 10. 2 times 10. So we have negative 90. Is that less than positive 20? Yes, that is true. Divide both sides by 5. Negative 9 divided by 5. Is that less than 2 divided by 5? Okay. Well, negative 9 divided by 5, if we're going to turn it into a decimal, which is probably what you guys would prefer, it's negative 1.8. And then 2 divided by 5 is 0.4. Negative 1.8 is less than 0.4, so that's still true. Okay, now multiply both sides by negative 6. So negative 9 times negative 6. 2 times negative 6. Negative 9 times negative 6 is positive 54. 2 times negative 6 is a negative 12. Is 54 less than negative 12? That is not true. It's false. Okay, divide both sides by negative 3. Negative 9 times negative 3. 2 times, or divide, right, by negative 3. Negative 9 times divided by negative 3 is a positive 3. 2 divided by a negative 3 is negative 2/3, which we negative 0.6 repeated, which 3 is definitely not less than that, so again, false. So looking at these, what operations, when performed on an inequality, reverse the inequality? In other words, we would have to change it, right? To make this work, I'd have to change it like this, wouldn't I? Okay, and what we should notice is it's only when we multiply or divide by a negative number, okay? Only when we multiply or divide by a negative. Which, if we go back here, we should notice number 4, okay, we're dividing by a negative 10. I flipped the inequality, reversed its direction to make it work. Same with number 8, okay? So when we talk about those differences is the equal sign or inequality sign. Okay, the other difference is the answer. Okay, equation is just one, inequality is multiple. And then when you divide, or in other cases multiply by a negative, that causes an issue, okay? So if we're thinking about this, what would we say if we needed to teach somebody how to solve inequalities? Well, hopefully you'd say it's basically the same as solving an equation with a few differences. Okay, the way your answer is, and if you multiply or divide by a negative. But other than that, it's really the same as multiplying as solving a regular equation. So pretty similar, okay? It is similar to solving an equation, except for the meaning of the answer and multiplying and dividing by negatives. Okay, everything else is pretty much the same than those two things. All right. Okay, so one thing to probably mention here, the reason this is when we have issues, it basically has to do with the number line. Okay, we kind of have some number lines down here. We'll talk a little bit about this, but with the number line here, the idea is that if I have a positive number like this 7, okay, and I times it by a positive, it becomes a bigger number up the number line. If I times it by a negative, it becomes a bigger number in a sense, but then it flips it over, okay? And that idea that it flips it over the 0 is what really makes us have to change how we treat it, okay? All right, so sometimes we have to graph these inequalities. So a few things to remember. Okay, there's 4 different types of graphs. You have less than, more than, less than or equal to, more than or equal to. Okay, the main thing is the shading and the circle. Okay, so with the shading, if the variable is smaller, like this, x is less than 7 or 7 is greater than x, we shade to the left because that's where the numbers are smaller. If x is greater, then we shade to the right. If it's just less than or more than or greater than, our number that it's greater than is like the edge, but we don't fill it in. If it's equal to, we fill in where we start, okay? So we have to decide if the circle is filled in or not, and then we have to get the arrow in the right direction, okay? So for example, if we had something like, x is less than or equal to 8, okay? I would have to go on my number line to 8. Then I would decide, I draw a circle here. Is it filled in or hollow? That equal to means it's filled in, so I fill it in. Then is x bigger or smaller? Smaller to the left, bigger to the right. Smaller, so I shade to the left, okay? All right, guys, so now let's look at these examples, okay? So again, we treat them just like we were solving an equation. So an equation, I'd say, first we take x, times it by 3, then add 6. But when we're solving, we do the opposite. So I would subtract 6 from both sides. Okay, and remember, thinking about those notes, when we add or subtract, it doesn't matter if it's positive or negative, the inequality is going to stay the same. Negative 30 minus 6 is negative 36. That becomes 0. We get 3x divided by 3 on both sides, dividing by a positive number. Now here's something. Okay, this number up here is negative. That's all right. It's when the number down here is negative that we change the inequality. So still less than or equal to. Negative 36 divided by 3 is negative 12. This becomes x. Okay. All right, number 2. So we subtract 9 from both sides first. That becomes 0. That negative stays with our 4a. 13 minus 9 is 4. Now I divide by a negative 4. Now this time that's negative, so that becomes 1. That becomes negative 1. But now my inequality has to change direction because down here is now negative, okay? All right, number 3. Add a 2 to both sides. I get m over 3 is greater than 6. Times by 3 becomes 1. We get m is greater than 18. No change in my inequality because I didn't multiply by a negative. Now number 3. Subtract 1. We get 2. 3 minus 1 is 2 is greater than or equal to negative x over 9, which that negative, you can kind of treat it as like a negative 9, or the fraction's negative or x is negative. The easiest thing, though, for us is to really think of it as a x over 9 to the negative. Then what I do is I just multiply by a negative 9. Gets rid of my negative and my 9. I'm left with x. Negative 9 times 2 is negative 18. But now I multiplied by a negative, so I change my inequality. Now here's something to think about. Okay, when we subtracted here, negative stayed negative. When we divided here, negative stayed negative. Didn't change my inequality. Here, positive changed to negative, so I had to change my inequality. Just like down here, times negative changed to positive, had to change my inequality. Okay, same with this. Positive stayed positive, didn't have to change it. Okay, so when we have to change that positive to a negative, positive 2 to a negative 18, okay, that's kind of a key as to when we are dealing with some issues. All right, looks like we just got a few more examples. Okay, so n plus 1 divided by 16 is less than negative 1. I would start by timesing both sides by 16. That becomes 1. N plus 1 is less than negative 16. Okay, now again, negative but stays negative, so I don't change my inequality. Subtract 1 from both sides. I get n is less than negative 17. Now, number 6, two ways I can do this one, right? First way would be to distribute. I get negative 6 times a minus negative 6 times 3, which would be 18, so minus 18. It's greater than or equal to negative 42. Add 18 to both sides. Get negative 6a is greater than or equal to 24. Yeah, negative 24. Divide by negative 6. And I would get a is less than or equal to, right now, going negative, this is going to turn into a positive 4. So because of that, I had to change the inequality, the direction. Now, I could have also started by dividing by negative 6 to begin with, couldn't I have? And I would have got a plus 3, and then change my inequality is less than or equal to positive 7. Subtract 3. A is less than or equal to 4. Okay, last two examples. So we can combine some like terms. Negative 5 and negative 4 would be negative 9. Positive 11 would be a positive 2 minus 5v is greater than or equal to v plus 8. Now, many different options I could do here, and I'm going to show you two of them because I think it'll help you see some things. So maybe I decide to minus v. I would get 2 minus 6v is greater than or equal to 8. Subtract 2. Negative 6v is greater than or equal to 6. Divide by negative 6. I'm dividing by a negative, so it becomes less than or equal to negative 1. Now, what if I said I don't want to deal with a negative like that, so I'm going to add 5v to both sides. I get 2 is greater than or equal to 6v plus 8 minus 8. And I get negative 6 is greater than or equal to 6v divided by 6. I get negative 1 is greater than or equal to v, which, if we think about it, if I flip-flop this around, it would be v is less than or equal to negative 1. So you're going to get the same thing regardless of how you deal with it. Okay? All right, last problem. Distribute. You get 8x minus 9 is less than or equal to 3 times x plus 3 times 8 minus 8. 3x, then b plus 16. 24 minus 8 is 16. Could add 9 to both sides, giving us 25 plus 3x is greater than or equal to 8x. Oh, not divided by 8. Subtract 3x, right? That would become 5x is less than or equal to 25. Divide by 5, and x is less than or equal to 5. Which, again, I could have done things an opposite way and ended up with having to switch the inequality sign. So there's some examples of how we solve inequalities. Again, same idea is to deal with it like it's an equation. except for when we add or subtract or multiply or divide by a negative number and recognize that our answer is